Hello and welcome to a new episode dedicated to the columns. We continue the series. In this one, we'll learn how we actually can build a dynamic block, like the elevation of the column. So, without further ado, we'll just dive in. To simplify the things, we shall build a two-level columns. So, what I have here is a basic drawing in AutoCAD, comprising in lines, dimensions, some texts, maybe some symbols like the level one, and some special lines dedicated to a special layer, which will have the name of guiding lines, let's say, and it's meant to help the dynamic block and transmit the data via fields to various objects like the text. You will see. This type of lines are actually just helping the block, but will not remain in the final drawing. We will discover this step by step by building the block. So the first step will be, at this point it doesn't matter if you are a beginner or intermediate in AutoCAD, we'll just dive in and learn it as we go. We'll start by making a static block. That means we're going to choose the objects of the future block. We're going to press the B key to actually start a new definition. So we must have here allow exploding marked, convert to block. We shall name the block lev 2, let's say, from 2 levels. We shall pick a point for the base point, and just by an agreement we shall take the base of the column on the left part. We're just going to click it. It's gonna show again the tab, and we're just gonna press OK. So in this moment we have created a static block, which is a collection of entities. Just like I said, if you're entering it, double click it, an edit block definition tab will appear with the name of the newly created block, and we're gonna press OK to go inside and edit it. So the static block is just a collection of objects starting from a basic drawing, the lines, the dimensions, the symbols, the text, okay? And what's the purpose of the static block? Well, if we want to draw something and we wish to have it on our drawing on a repetitive level, all we have to do is just call it by pressing the I key plus enter. That means we have to insert the block into the drawing. We already have the name here, so we're going to press OK and just place it by repeating the command wherever we want, how many times we want. So this is helpful when we want to have a repetitive object all over the drawing without copying it and paste it or create it from scratch again and again and again. And what is specifically, because that is not all, every time I decide to make a change and I want it to be seen in all the insertions, we actually have to choose only one definition, only one instance of the definition, let's say this one, and make a small adjustment, like for instance drawing a circle. Okay, so that means we want to change the overall drawing by adding a circle, and we want this circle to be seen in all the instances. We just have to close and save the modifications in this block, And now all the instances have the circle inside. So this is the major advantage of the static block, because it's enough to modify only one instance and all the instances will take that modification. Okay? So, starting from this static block, we will now create the dynamic block. Okay, we're just going to delete this. I'm going to enter once again the static block because I want to get rid of the circle. And the starting point is this table over here that will show the parameters tab, the action tabs, the parameter sets, and the constraints. But in this episode we will concentrate on the parameters. And we'll take it simply with the first one, the base point. Okay? We already constructed the block by choosing the base of the column on the left side. But we can actually put the base point parameter either if it's a static block or especially if it's a dynamic block, and especially if this dynamic block will work along with a Lisp command. The base point parameter is vital to be placed. Why? Because the future parameters, along with the Lisp, again, all the parameters will have their lengths and starting and end points taken into consideration by the Lisp command in respect with this base point. So this is actually vital when we are constructing a dynamic block that will be in the future used with the Lisp. If the dynamic block will be used just from the AutoCAD, this base point parameter is not necessarily compulsory to be placed. But if you are using it with the Lisp, it becomes a non-negotiable thing. Okay, the next important parameter that we're going to use in the vast majority of the block is the linear one, which in the vast majority of the cases will be used orthogonally. So we can place it horizontal, and by repeating the command we can place it vertical. Of course, if we cancel the ortho mode, we can use it at any angle. Okay, but this is a case that I almost never used. The parameter works along its own axis, so this one, if it's constructed horizontally, will have this starting grip and end grip working on the X direction. This one will move or stretch things plus or minus on the X direction, and the other one as well. So the parameter comes with both ends. Now you must pay attention because this is very important. You must take into calculus what exactly do you want from the block to do. What do you want? Which is the way you want it to stretch it or move things, because the starting point of the parameter and the end point are very important about this thing. Why? Primarily, the end point will be the one that will bear the actions. I said primarily because, in fact, they both do, but if for some graphical reason I do not wish to see both of the ends active from outside the block, I can choose that parameter, go into the properties tab, and here from the number of grips, which is marked by number 2 now, meaning that both of the grips are visible, I can actually choose to see only one, and that will always be the second grip, the end grip. Okay? Or some or if for some reason I want the parameter to be inside the block and bear an action, but I do not want from any kind of reason to see it outside the block in the properties, I can choose the parameter and actually give it 0 visibility on the grips. That doesn't mean the parameter is cancelled or anything. No, it will still be in the block, it will still have actions, will still activate different parts of the drawing, but not with visible grips. That it means it will not, you couldn't manipulate it in the properties tab outside the drawing, but only via Lisp command. Okay, so why would we want to have 0 grips? Because we probably consider this parameter as a secondary one, and we do not wish to overload the drawing with unnecessary grips. But as long as it is an important parameter, we shall leave it at least with 1 visible grip that can be actually accessed from outside the drawing, manipulating by hand, by Lisp command, and so on. Okay, so what I want to show you next, we're just going to exit this block just for a little bit, and we're going to choose an already constructed block. Okay, just pick it. Now you see the grips of the parameters, and what you see in the properties tab, these values are actually the actual length of the parameter. So this is very important to bear in mind, because when we are constructing the block, okay, we're just going to enter again. Let's say we want to manipulate the height, the first height of the first span. Okay, the height of the first column on the first level. So we already have it dimensioned, it's 300 centimeters. If we want to see this value outside the dynamic block, the block will not read this dimension, will actually read the length of the constructed parameter that will represent the height of the level. Okay, I hope it's clear by now. Let me exemplify. So, because this is the base of the column, it's common sense that I want this column to develop upwards on the positive y-axis, right? It's like taking this drawing and using the basic stretch native command, okay? It's just like pulling upwards the column level by level, okay? So that means if I want to construct the length of the first level, I must choose a linear parameter. I'm making sure that the ortho is activated, and let's say we place it here. This will be the base point, and this will be the end point, and the length of the parameter will actually match the dimension of the first column, 300 centimeters. Okay, so we can actually read it in the table by selecting the parameter. We're going to the geometry at the distance, and we have 300. So one basic philosophy is to actually think of these parameters as the dimensions of the element you want to stretch. If you want to have a clear measure of the object from outside the block, I think this will be the most important idea for a beginner to understand. If you want to read the exact value of a certain body, just think of this parameter as its dimension. Okay? So as I said before, because I only want to move the column upward, I don't need to see the starting point of the parameter. So as I said, I'm choosing the parameter, I'm going to the number of grips, in the property table, and I'm going to choose 1. Okay. Now for the second level, of course, I can make another parameter with the starting point beginning where the first one ends. It's logical, right? Click and then just go on top of the second level, and this will be the future active point of the parameter. Click it and arrange it aesthetically a little bit, and the third click, I'm finishing the placement of the parameter. I take this one as well and set it with just 1 grip. Okay, now in order to recognize the parameters from outside, it is important to give them a proper name. They come by default with the distance 1, 2, 3 and so on in the order which you have created them. But if you want to know precisely what a parameter does, it's vital to place a name, thus knowing what is meant for, and especially when working with Lisp, the Lisp will know which one to manipulate, okay, and make use. So normally you can put any kind of name for this parameter. We're going to the properties table again, and we have this in the property labels distance name and distance 1. We shall replace it with a common name. Okay, so if you were working manually with the dynamic block without using any Lisp command, you can put any kind of name and symbols. Probably you will say level pause 1, okay, with small caps, with a pause between level and 1, and now you know from outside the table. Okay, let's just close and save it to demonstrate it. By choosing the block, we're going here and you see the level 1 300 and the unnamed second parameter distance 2 300. So you already know you are referring to the first level by placing a name. You know precisely, we cannot mistake it with another parameter. Okay, but because these dynamic blocks will be used in the future with Lisp commands, okay, because this is the main issue of this channel, to make the dynamic blocks work along with Lisp and make it faster, we must bear in mind the next issue. The Lisp doesn't like names that have, let's say, a pause between letters or symbols, and often it likes to have the name with big letters. Why? Because in this way it will not mistaken various parameters or different variables and so on. So as far as I can tell you, the Lisp command likes it very much for the parameters to have a precise one string without breaks name, and often with capital letters to be very clear. So probably it should make more sense, it will be more simple if we just rename it with capital letters lev 1, one string, okay, and the second one we shall name it lev2. Alright, now when we are constructing a dynamic block, of course we must have a clear picture in our head. What do we want from that block? So we must take, at least at the beginning, into consideration the vast majority of the possibilities that we want to achieve with that block. So in this case, I have the height of the levels. What do I want to do with the column? Of course, I want to manipulate the cross section of the column. I want to manipulate the height of the beams. I want to manipulate as a secondary option the span of each level, not necessarily the level but the span of it. So if I'm thinking of it, I must create new parameters that will take this into consideration and will be used in the future. So let's say we want to manipulate the cross section. You gotta think of it, what do you want to obtain from it, in which direction it will move, how you can make it not interfere with the rest of the drawing. So because we can actually work with bigger cross sections, we don't want this part to overwrite the main drawing. So concerning the height, let's say this one of the cross section, maybe we want it to be developed downwards, okay? And the width of the column, maybe we want it to develop just as an agreement from left to right, okay? So in this direction. Now, perhaps you're wondering why am I using such a broad width of 100 centimeters and such a broad height? Well, the answer is quite simple. When I'm starting a new definition, I do not want to have a cramped drawing, a very narrow one. I want to work freely with the spaces and choose, let's say, the width without too much problems, okay? It's a big, clear drawing. I can place the mouse easily in the middle and create an area. The same with the levels, okay? So, of course, you can make a more compact drawing, but if you are working with a multitude of parameters, you will see it will get very tiring for your eye or your brain to select precise zones in which to create parameters and actions. So get your drawing a little bit loose, okay? Because this will be just the first step of your column. You're just going to insert an instance, and then you're going to manipulate it, reduce it to 30 centimeters. It will not be a problem. You can do it parametrically from outside. But when you are creating it, don't be cheap, okay? Just use a large drawing. Make it easy for you as a human to actually decide the certain areas you want to work with, okay? So, as I said, we want to place the base of the column. So if you want to develop it from left to right, that only means the base point will start at the left and will end at the right, okay? And the height actually will start somewhere here, or maybe here, or maybe even in the middle, because when you're creating a new block, of course you must decide which parameter are compulsory to be placed in a certain way and which ones do not matter after all so much. This will come only with experience, okay? So there's no direct teaching where to place a parameter, where is the starting point. It's just common sense. Just think of your block, of what you wish to extract from it, okay? So in this case, it doesn't really matter. All I know is I want this section to develop downwards, so I will just place by starting here and ending here, and the third click to place it. So of course we take this one and this one, and we want to let it with just one grip, okay? And we want to name this is the base of the column. We're just going to call it base, and this will represent the height of the section, so we're going to call it height. Okay, what next? As I said, the height of the beams on each level. Why? Because in the future, when we are going to place the stirrups on the first span, we actually going to need to place another set of stirrups in the nut of the column and the beam, and probably because these stirrups will be very much different from the actually span ones, it's important to know to actually edit the height of the beam, thus knowing the number and spacing of the nut stirrups. So in the vast majority of the cases, the beam will develop downwards, of course. So we're going to place the starting point of the parameter that will determine the height of the first beam on the top of the level and going downwards on the beam. Okay. Of course, we want to see only one grip, the second one, and we're going to call it beam 1, let's say. Okay, we're going to place the second one, one grip, call it beam 2. And as I said, maybe sometimes we want to draw the body of the column by editing the span of each level. So the span will develop from the base of each level upwards. That means we will construct it with the base point from down upwards. Okay, and make it for the second level as well. We just want to see the second grip on each level, the one that will push the column upwards. Okay, so we choose the two. We gave them all together only one grip, then we choose only one and rename it span 1 and span 2. Okay. So as far as I'm concerned about the parameters of this type of column of 2 levels, I think these are actually enough to edit. Now, a second issue for the column is to have certain texts and like the value of the cross section and the type of the column and the number of pieces of the identical columns, or the levels of the column to be edited and turned into fields according to what I've told you in the beginning of the episode, with the help of these lines with this layer, which are called guiding lines, that at the end of the drawing in the final file will be actually discarded, because once we completed the drawing, we are exploding the block, we are going to kill all the fields, and we will process the data, the rebar marks and the numbering in an extract, and we don't actually need but the final form of the drawing, which will be a basic AutoCAD drawing. And afterwards this line will be deleted and purged, because the final drawing will reach the client without these ones, but a normal drawing. The idea being of constructing it rapidly by using dynamic blocks and Lisp command. Okay, so the main philosophy is to construct it rapidly by these techniques, and afterwards placing the drawing to the client, just a normal drawing. Okay, so this is just an internal issue for us to construct it rapidly and precise. Okay, let's see now how we can turn these values to take a field that will make these values variate according to the values we want for the column to take, meaning the cross section. So without further ado, we're just going to dive in. Doesn't matter if you're a beginner or if you're an intermediate. I'm just going to show you, just plunge into the problem, how we should transform this static value into a variable one with the help of the field. So we're going to go inside the text and just select, no, just a small problem. We're going to select the part of the text we wish to transform, click right, and search for the insert field option with the shortcut of Ctrl F. And now from here we have to choose from the field category object, from field names also object, and from the object type we shall push this button and choose the graphical object that will transform this value into a new one according to the field. So what object can we choose? Of course we can choose either this one or this one. In this case is the same, is the value of the dimension that represents the base of the cross-section of the column. So we're going to choose the dimension, and what we are interested in is the measurement of it, and with the current precision of 0, because here in this preview we want to display the full value without numbers that are after the comma. So we're going to choose the 0, and from the preview it's going to show 100. Press OK, and now the field is taken. If we just click outside the text, congrats, you've just created your first field. So now to exemplify what I just did, if from outside the dynamic block we're going to manipulate by number or by group the base parameter, of course this dimension object will also modify. So let's say it will take this value, okay, 260, because we worked with current precision of 0. If we hit regen and press enter, you will see this field is automatically updated. Okay, so that's the main goal with these fields, to transform, to take the new values according to some objects and actually display the true new value of an object. Okay, we're just going back, and now we're going to make the second field, which represents the height of the cross section. Again, choosing the value. This time we, instead of control right any cell field, we can apply quicker the shortcut Ctrl plus F. Again, object type, and we are going to choose the second object that will determine the value, so the second dimension. Again, we want the measurement, and again the precision 0, because we want to display also 100. Hit OK. Now we have the second obtained field, and because we came back with the first dimension to update the fields, hit regen again plus enter, and it's updated. Now the type, the column type, 1, 2, 3, 4, how many types we should have in a project. Of course the dynamic block would not know how many types of columns do you have, but we can introduce this value by hand from outside the block, of course, via a parameter. But of course we have to read first with this number, and with the help Ctrl F, with the help of a small line with that special layer. So here we have the first line. Just choose it, and we want the length this time, 0 precision, so it will display the actual length, which now it's equal to 1. Hit OK, and we'll have 1 in the field. But how can we manipulate this from outside? Of course we have to build now the parameter that will actually lengthen this line that we used to create the field. So we're going to the parameter, create one from left to right, and because we don't want to see any grips from outside, we're just going to change the values by hand. We're choosing it, and we're going to give 0 grips this time, okay? And we're going to name it type. So we have the type parameter that will actually lengthen this line, and this line by its length via field will give this value for the type of the column. Okay, so how many numbers of the types? Of course, again, we're going to make a fourth field, Ctrl plus F, and choose another helping line, the second one with the same one length at the beginning, length 1 in the preview, okay. And of course, to manipulate, we have to create the parameter. Again, from left to right, and with 0 grips, because we also want to introduce the numbers without seeing the grips from outside, and we're going to call it number. Okay, so you've just created your first fields. Okay, we shall address now the last issue for this tutorial, namely we shall transform into fields these values that represent the heights of the levels in respect with the base of the column and the depth of the foundation. So first we shall give this object a value via a field by with the help of this small line, which comes by default with a length of 1, and we shall choose the number without the minus sign, taking into consideration that this will be the base of the building, which in most of the cases comes with a negative value, because as you know, the 0.00 level is actually for the finishing of the base, the architectural finishing for the base of the building. So by default we shall use a minus value, and we will make that this number will become from the dynamic block the length of this line, which will receive also a parameter in just a few seconds. But let's build the field first. So we select what we need, we hit Ctrl plus F. Okay, we're going to need the object, and from object type we shall press select object, and we'll need the length of this line. We're choosing length with the precision 0.00. It's okay, so the preview says 1.00, and we shall make this to become meters. So now we can put the parameter, which will be a linear one as well, the base point, the final point. Also, we don't need to see the grips, 0 grips, because it will be changed only from the table. And we shall call it level, and in parentheses we shall put meters, so we know that when we introduce the value we'll have in mind the meter. So we will, for this instance, by default we could say we have introduced 1, but if for some point we want to say minus 0.1, we shall simply introduce in the table 0.1, and this all will transform into that value. Okay, now for the first height of the level, this object right here, how can we transform it to actually become the height of the level, which in this case by the block construction is 300 centimeters. How can we make it take the value of the base plus the value of the first height of the level? Well, we can make a field, hit Ctrl plus F, and actually make a formula. So in the field category we choose formula, we're going here, and now we can make a field, also hitting Ctrl plus F. Now we are on the object, we're going to choose an object, and we're going to choose actually the first value that took the first field from the line, and from it we're gonna take the content this time. In the preview we have the current value -1, okay, and then plus the height of the level, which again Ctrl plus F, we're selecting an object. And what object? We're actually selecting this dimension, this quotation, okay? And we're gonna need the measurement, and in the preview it gives the full value 300, but because we want to transform it into meters, we're going to divide it by 100, and then we hit evaluate, and we choose the 0.00, and in the preview we have 2.00, okay. The additional format, it remains as it is, conversion factor 1, and we hit OK. So you're not going to see now a drastic change in the value, because it was already constructed by having in mind that from the start it's +2 meters in respect with -1 meter plus 3 meters. So -1 plus 3 will equal +2, okay? So for the time being, you're not going to see here in the definition of the block a variation of the value, but if we're going outside after we also put the actions on the parameters and we're going to change this value, you will see that this one will change accordingly to this value, and also depending of the variation of this value, okay? I hope it's clear. You will see it in the episode dedicated for the actions added to the parameters. So now I'm going to construct for the next level, which also comes with a predefined value of 5, which of course is the last value 2 plus the next 3 meters. Of course it will equal 5. So when we're going to construct now the last field, you will not see a drastic change. Actually, you will not see a change of the value, but you get the idea how in the future the block will get its true value when we vary this one and also vary this one. So again, this will become a field, Ctrl plus F, again formula, Ctrl plus F, and what we're going to choose as an object? Well, the last text object which received the last field. So we're going from one value to another. The basic value plus level, the obtained value plus level, and so on, taking into consideration that we will, for the other columns, will have many stories to build, okay? So this will choose this object, of course its content, okay, 2.00 as a preview, and plus again Ctrl plus F, object. This time we will choose the next dimension that represent the next height of the level of the column. Again, we're going to choose the measurement, hit OK, and also divide it by 100 because we want to convert it to meter. So we have 2 meters plus 3 meters, and we can see in the preview we obtain 5, but we want it to be 5.00 meters with this precision, hit OK, and now we obtain this value. Okay, and for the last part, how we can obtain the correct value in respect to the base of the depth of the foundation. Well, we're going to choose the whole, this time the whole text with minus also. I think I'm doing correctly. And we're going to choose, of course, the base first, its content. No, we must make the formula. Of course, we must make the formula, not directly the object. Ctrl plus F. Now we choose the object, which is this one, the content. Okay, and now we hit a minus because we're going downwards with the values on the negative side, right? And Ctrl plus F to choose now the object, what the value of the depth of the foundation, which of course is the measurement. It's 40 centimeters, but transform it to meters divided by 100. We hit evaluate, and with the current precision of 0.00, we of course obtain what is normal to obtain. -1 minus 0.40 will of course give us -1.40, the level we desire. So if we shall vary this value from outside the block, this will also follow the true value. Okay, so we now have all the parameters that we need, and we constructed all the fields. For the next episode, we shall address the actions attached to the parameters, and actually we shall complete this dynamic block for a 2-story column. Okay, I hope you enjoyed it, and I'm waiting for you to watch the channel and watch the new episodes. Bye bye.